Today we're looking at Unit 8, Lesson 9, with our aim being able to compare and order numbers written in scientific notation. Our Think About It asks us to use an inequality symbol to compare the numbers written in scientific notation. Let's look at our first example. I have 8 times 10 to the 4th in comparison to 7.6 times 10 to the 4th. What can we do in order to compare these numbers? Well, let's just first turn our numbers into standard form. I know I have 8, and we need to move our decimal place over 4 spaces. I'm left with 80,000. Over here on the right, I have 7.6, and again, I'm going to move my decimal place over 4 spaces. I'm left with 76,000. When we're comparing those two numbers, it's obvious that 80,000 is bigger than 76,000. So we can use a greater than symbol. I have 9.67 times 10 to the 3rd power in comparison to 3.45 times 10 to the 4th power. Again, let's go ahead and expand these numbers out. So I have 9.67, and I need to move my decimal place over 3 units. So I'm left with 9,670. Over here on the right, I have 3.45, and I'm moving my decimal place over 4 spaces. So now I have 34,500. When comparing those two values, it's obvious that 34,000 is much bigger than 9,670. Now, let's look and see if we can compare our numbers without even having to expand into standard form. When we're looking at our first example, 8 times 10 to the 4th and 7.6 times 10 to the 4th, what do we recognize about those two numbers? We're multiplying by 10 to the 4th. I know that b is equal to 4 in both cases. So that when we're comparing those two numbers, we don't need to compare 10 to the 4th. We know that those two things are the same. I'm comparing 8 and 7.6. I know that 8 is bigger than 7.6, so I know that 8 times 10 to the 4th is going to be bigger than 7.6 times 10 to the 4th. In this case, we're comparing our multipliers. Because our exponent is the same. Now let's look at our second example. In this case, what do we recognize? I can recognize that I have 10 to the 3rd over here and 10 to the 4th over on the right. I know that b is equal to 3 on the left and b is equal to 4 on the right. That means that when I'm comparing those numbers, something to the 4th power is going to be bigger than something to the 3rd. So in this case, we're comparing our exponents. So then we're looking at our question at the bottom, and it's asking us to explain how we can efficiently compare numbers written in scientific notation. What two things can we compare when we're written in scientific notation? Go ahead and jot that down on your paper now. We know that we can compare exponents and multipliers when comparing values in scientific notation. That's going to be the conjecture that we work with today as we're going through our packet. Go ahead and turn the page to test the conjecture. Test the conjecture number 1 asks, which number is greater, 7.3 times 10 to the negative 4th power or 3.1 times 10 to the negative third power. Let's look. What two things can we compare when we're comparing values in scientific notation? We can compare either the exponents or the multipliers. When we're comparing values in scientific notation, we always first want to look at our exponents. So our exponents are -4 and -3. When we're comparing those things, what do we recognize? Well, when we look at our integer rules, I know that -4 is less than -3. So if I'm taking something to the -4th power, I know that's going to be smaller than something to the -3rd power, which means 3.1 times 10 to the -3 is greater because -3 is a greater exponent than -4. Now that we know how to compare values in scientific notation, why don't you go ahead and start number 2 of Test the Conjecture on your own. Order the numbers from least to greatest. So our numbers are 1.01 times 10 to the 4th, 4 times 10 to the -3, 3.9 times 10 to the +3, and 1.1 times 10 to the 4th. What is the first thing that we should look at when we're comparing our numbers? The first thing we should do is compare the exponents on each number. So what are the exponents that we have? I have 4, -3, 3, and 4. When I'm comparing that, what is going to be the smallest of all of those numbers? -3 is the smallest. That means I know that 4 times 10 to the -3 is going to be the smallest number in this set. After that, I have 10 to the 3rd. That's the second smallest. So I know that after 4 times 10 to the -3, in my list, I'm going to have 3.9 times 10 to the 3rd power. After that, I recognize that 1.01 times 10 to the 4th and 1.1 times 10 to the 4th have the same exponent. These numbers have the same exponent. I need to then compare the multipliers. In my first value, I can see that my multiplier is 1.01. In my second value, I can see that my multiplier is 1.1. Now we need to compare these. Which is bigger, 1.01 or 1.1? I know that 1.1 is bigger than 1.01, which means that 1.1 times 10 to the 4th is going to be the greatest value. If that is my greatest value, then the next number in my list should be 1.01 times 10 to the 4th, with my final number being the greatest value of 1.1 times 10 to the 4th. Now that you guys know how to compare numbers by first comparing the exponents and then the multipliers in scientific notation, go ahead and complete your independent practice and your exit ticket on your own.